In this video, we'll discuss graphing the sine and cosine functions. In particular, we'll use a table of values that we obtain using the unit circle to plot graphs for y equals sine x and y equal cosine x, and we'll use these graphs to identify some basic properties of the sine and cosine functions, such as the domain and range and the period of the functions. In this video, we're going to take a look at how to graph the sine and cosine functions. Like with any other functions you've encountered in your mathematical lives, we're going to first plot these functions by coming up with several points on the graph, plotting them in the plane, and then connecting the points with a smooth curve. In order to get points on the graph, we're going to use the unit circle approach to defining sine and cosine by thinking of sine and cosine as the y and x coordinate, respectively, of the points on the unit circle. We're going to start by looking at the sine function. Here on the screen is a table of values for sine of x given a number of angles between 0 and pi whose sine values we should know. We have seen that sine of 0 is 0 and sine of pi over 6 is 1/2 and so on. The first half of this table are the first quadrant angles. The second half are the second quadrant angles, which were found by looking at the reference angle and then observing that in the second quadrant, the sine function is positive. And so, for example, for 2 pi over 3, the reference angle being pi over 3, we know that 2 pi over 3 and pi over 3 have the same sine value. So sine of 2 pi over 3 is the square root of 3 over 2. Right, so this table is something that you should already know, should have been able to complete on your own if you had to. Now that we have a table of values, we can plot these on the coordinate plane and sketch a graph through those points. And we would obtain this graph here. Notice there are 9 points indicated on the graph as black dots. Those are the 9 points corresponding to the table at the top of the screen. The graph continues here going from pi to 2 pi, and we didn't go through all of the other ones, but we could just as well make another table with all of the angles, the multiples of pi over 3, pi over 4, pi over 6 in quadrants 3 and 4, and we would see that they are the same values as what's in the table here, except they would be negative. And so you can kind of see that this graph would go down and sort of look a lot like the section from 0 to pi, but just be below the x-axis, be a reflection of that first half of the graph. And so this is a graph of the sine function from 0 to 2 pi on the x-axis. Notice that the graph, in terms of the y values, goes as low as -1. It hits that at 3 pi over 2. And it goes as high up as 1, which happens at pi over 2. And if we think about the sine as the y-coordinates of points on the unit circle, we can see that this makes sense. The y-coordinates on the unit circle are all between -1 and 1. This image here shows a little bit more of a connection between the unit circle and the graph of y equals sine of x. You can see on the unit circle on the left that there are 3 angles in the first quadrant that are indicated by a gray segment, and those would be angles of pi over 6, pi over 4, and pi over 3 when we move counterclockwise. Likewise, the angle at pi over 2, the 90-degree angle, is also indicated there. And the dashed line from the unit circle over to the graph indicates that we're looking at the y value of the point. And so the y value of the point on the unit circle is the y value on the graph of sine x. And that's the dotted horizontal lines in this case, indicating the connection between those y coordinates. So now that we have a graph of y equals sine x and see how it relates to the unit circle, let's do the same for the cosine function. So for the cosine function, we're going to take the same approach, and we're going to plot a set of points on the coordinate plane and connect them with a curve. At the top here is a table of the same x values from 0 to pi as we looked at for sine, and the second row of the table indicates the cosine of the value. Notice that the second quadrant angles, the ones starting at 2 pi over 3, are all negative because in the second quadrant cosine is negative. And now here at the bottom, we have the same 9 points plotted from x equals 0 to x equals pi. Those are the black dots there. Those are the points corresponding to the table at the top. And we plot all of those. And again, just like with sine, if we wanted to, we could have plotted from pi to 2 pi, and we would see that the points fall originally from pi to 3 pi over 2, they would be negative because those would be the third quadrant angles, and cosine is negative there. And then starting at 3 pi over 2, cosine becomes positive as we move into the fourth quadrant, and cosine becomes positive. So the cosine function from 0 to 2 pi looks like this. Again, notice that it ranges from -1 on the bottom to 1 at the top. And again, that makes sense because cosine represents the x-coordinate of the unit circle, and the x-coordinates of any point on the unit circle always are between -1 and 1. So we've now seen graphs of sine of x and cosine of x from 0 to 2 pi. So the next obvious question is what happens either to the left of 0 or to the right of 2 pi for either of these graphs. And to understand that, we need to think about how these trig functions are defined in terms of the unit circle and realize that there is going to be a pattern to these graphs and to the functions in general. We can do this by making the following observation, that the values of sine x and cosine x repeat every 2 pi units. So what this observation means is that the graphs of y equals sine x and y equal cosine x will both repeat after 2 pi units, just like the functions will. And so if we know what the graph looks like on any interval of length 2 pi on the x-axis, then we can just repeat that interval over and over and over again, and that will produce the entire graph for either the sine or the cosine function. So when a function has this property that a particular part of it can be repeated over and over and over again to produce the entire graph, we call the function periodic. And the length of that interval that we need to repeat is called the period. So in this case, what this is really saying is that the period of the sine function and the cosine function is equal to 2 pi units. We will see for the other trig functions that they have similar periods, although not always 2 pi, and that variations of sine and cosine can have different periods as well. But for sine and cosine of x, just the straightforward sine x, cosine x function, the period is 2 pi. So here are graphs for the entire sine of x and cosine of x functions. Of course, we see there are arrows on each end indicating that the pattern is going to continue indefinitely in both directions. But we can see here the part of the graph labeled 1 period that's between 0 and 2 pi is the graph that we developed earlier by plotting points and sketching a graph through them. And the rest of this graph is obtained by taking that period from 0 to 2 pi and just repeating that part of the graph over and over and over again to the left and to the right. One thing to notice about these two graphs is that they look extremely similar. In fact, if you take the graph of the cosine function and shift it pi over 2 units to the right, you will actually obtain the same graph as sine of x. And so these two functions, while they are different, have a lot of the same properties. Just one is shifted over from the other. This makes it very easy to analyze problems involving sine or cosine because we can typically use the same kind of strategies because the functions are so similar to each other. The way to remember which is by looking at the y-intercept for each of the graphs. Right? We should know that sine of 0 is 0 and that cosine of 0 is 1. And by looking at this graph, we see that sine of 0 must go through the origin, must be this point here, and cosine of 0 is 1, so it must start up here when we're at x equals 0. And so this is the key way to remember which function is which and which graph goes with which function, is by thinking about what happens when x is equal to 0. So we'll end this video by looking at some basic properties of sine and cosine that we can actually see from these two graphs. And so from those graphs, we can deduce the following properties of these functions. All right, we can see that their domain is going to be any real number, so in interval notation, negative infinity to infinity. We can have any angle, positive, negative, or 0, and we can compute their sine and cosine. The range, however, is between -1 and 1. That we can see from the graph, but we could also see that from the unit circle by realizing the x and y coordinates are all the numbers between -1 and 1. We've already seen that the period is 2 pi, that these graphs will repeat every 2 pi units. And we see that the y-intercept for sine of x is going to be at 0, and the y-intercept for cosine of x is going to be at 1. And we might also, if we want to think of these as points, this would be 0, 0, and this would be the point 0, 1. One thing to keep in mind is that this list of properties is only true for the two functions listed here, y equals sine x and y equal cosine x. If we make any kind of modifications to these functions, like, for example, if we look at y equals sine of 2x, then some of these properties may not be true anymore. In fact, the period of sine of 2x is not 2 pi, and we'll see this later. But just again, to point out that this bulleted list here, properties just of sine and cosine x, and not any modifications of them.